Savage Sullivan Math here. Today we are looking at the quotient of powers property. If we look at this problem, we have h to the 6th power k to the 2nd divided by h to the 5th power k. It looks like we are going to have to divide, hence the word quotient. I find it a little bit easier if I rewrite this so it looks like a fraction. If I rewrite this with the division bar like this, it's easier for me to see what I need to do with my bases. So if you line it up like this, you'll notice I've got bases of h right here, and I also have bases of k right here. The quotient of powers property says if you have like bases that are being divided, all you have to do is subtract the exponent. So here, this means that this would be the base of h with the exponent of 6 minus 5. Well, I know 6 minus 5 is 1, so it'd be h to the 1st power, or just h. For the k's, these are like bases, so I'm going to do k to the 2 minus there is no exponent written there, but remember, every base has an assumed power of 1 unless something else is written there. So this would be k to the 2 minus 1 power. 2 minus 1 is 1, and we don't have to necessarily write that 1, so it's just k. Final answer is HK.
Great job, Mrs. Sullivan. But what happens when we have an expression like this, where there's coefficients involved? Well, we're going to follow the same process. So when I look at this, I'm going to underline a couple of different things. I'm going to underline the whole number coefficients, because I know that I can work with those together. And again, I'm going to look for the terms that have like bases. So m to the 7th and m to the 3rd have the same base of m, so we can work with those. We can also work with the n's because n to the 4th and n squared have the same base. So even though they're written as one big term, we can work with each piece separately. So I'm going to go ahead and I'm going to start with my whole number coefficients. So I know that 28 divided by 7 is 4. So I'm going to go ahead and I know 4 is going to be part of my final answer. Then I'm going to take a look at my m's and I'm going to say, well, I know that m to the 7th and m to the 3rd have the same base, so I can work with them. And like Mrs. Sullivan said, because we're dividing, we are going to subtract those exponents. So this is really m to the 7 minus 3. 7 and 3 being my exponents. And then I'm going to look at my n terms, and I'm going to say n to the 4th divided by n squared. Well, that's really n to the 4 minus 2. Again, you won't have to put this middle step, just showing you where these are coming from. So now we're going to simplify what's there. So I know that I can subtract 7 minus 3. So I'm going to carry the 4 down, can't do anything with that. 7 minus 3 is 4. So m to the 4th power. And 4 minus 2 is 2. So this would be n squared. So when I look at this to make sure that I have simplified everything that I need to and that I can, I notice that first of all, there's no other whole number coefficients involved. So 4 is 4, can't work with it anymore. I also notice that m and n are different bases. So I cannot do anything with the exponent of 4 and 2. Some people like to add them together and make that silly Sally. We can't do that. These are not the same base, so we can't apply the product property. So our final answer is 4m to the 4th n squared. Easy. If you found this video helpful, please like and subscribe.